that you'll begin to even appreciate this year. Okay, so we're still in this. Here's a review from yesterday. Are you ready? There it is. Do you remember this? The Phoenix. Come on. And we got to somewhere. I'm clicking away. Oh, all right. We got to that slide. I think we did a couple examples, and that's where we stopped. So today our goal is to do three things. Our goal is to talk about the derivative of the natural log function, the derivative of log base A. That kind of follows the progression we did with the exponential functions too. And then to introduce a new differentiation technique called logarithmic differentiation. Okay. So I'd like you to derive this yourself. Y equals ln x. Okay. Derive, please, the derivative of that. I have one hint for you. How about the words implicit differentiation? Right. Anytime. In fact, you've seen us take this approach before, haven't we? Like when we were doing inverse sine, for example, right? Well, this is inverse e to the x, isn't it? So anytime we have an answer, we have a derivative, and we want to find the derivative of the inverse, we might have a method available to us. So give it a try. See if you can take that same approach, and just see if you can do it. It's more satisfying if you do it. And then I'll show you how we did it, too. I'm sure my work will look identical to yours. Go. Prove it. This is like the whole point. Right? I don't care about the answer.
It's not right. It's not right. It's hard to e into y.
In fact, difference equation is like
oh yeah, you're right.
This will have a lot of words.
I got e to the y times dy dx.
That's the textbook we use.
Same as y. Yeah. E to the y.
You get it?
No. Wait. We can plug y. We can plug y back in. Stop.
Take my hand. Take the rest of my hand.
Wait. Plug in y from x. Which is just look.
I memorized it.
Now plug in y equals ln x. Yes, but I use it better way. It's not a function of x. It's whatever you y over x. Right. So e equals 1 over ln x equals 1x. Oh yeah. If it's an answer, I'm really happy. Yeah, you're right. It's awesome.
Wait, no.
Which means it's the 1 over x. Y over x. And like, would your mind do it all makes sense, but it doesn't make sense. It makes sense. That's forever immortalized. Wait, you would do this class today, watch this. Yeah, we're done. Wait a minute, figure it out? Yeah, I'll go take my next lecture.
The math says it, then the test must be right. Is that what you got? I can't argue with that, I guess. I don't know. You don't need my improvement.
Yeah, go put this away. Yeah, hand me over.
Desired result.
Do you guys
Do what?
Yes.
Get the desired result.
I want to get it.
Out of 30.
We just made some noise now.
Literally on lunch today, like there were like 3 people saying all the software and adding software. So like between that.
Oh, did your entire group just split?
Yeah, so like normally we have like 10 people, like today we have like yeah. It's okay though, because I'm usually although I'm in trouble. So Ethan was lying down and Dave was threatening to pour water over me. Dave just that's why when you see my belt line,
All right, did you do it? Did you take this first step? Yes? All right. And then you took derivatives? And then you solved for dy dx? And then my extra challenge was please find this as a function of x. Well, mainly because it's better than what we have now. And of course, e to the y, we already started with that, is x. So did you get 1 over x? And there it is in a box now. Now you know you really mean it when we put it in the box. Good job. But like I said, often if you look at it, it'll actually be like if you're looking at exercises, the solutions will or maybe you just need to look at those cases, the solution of the exercise. It's actually the problem. It's there. It's right there with you. All right, you still need that for a second? I mean, all of you derived it just now, right? 1 over x? Okay. By the way, I mean, that makes me think, you know, in some sense, that makes me think that ln x has this close relationship to polynomials. Like, the derivative of ln x is just x to the negative first power. I mean, it almost feels like, and then from there on down, it's just you're using power rule if you want to take the second derivative of ln x, right? It's an interesting thing to notice that, like, we get something that doesn't have a log in it or anything. Was that good? Were you good on that? Yeah. I'm there. Okay. What about log base a of x? Again, can you do this one, please, by yourself? Yeah, use the previous result together with your pre-calculus knowledge. And if you took AB and you know the answer, again, prove it though, right? Prove it right now. You've probably never proved it to yourself. Prove it.
Wait, e to the y equals x, right? Yes. So, a to the y is y dx. Sorry. Now we're going to plug in log a log x. So it's x. No, yeah, so, no, I disagree with you. You are plugging that in as though with the second derivative, we know the formula for the first derivative is ln x. We know it was ln x. We can't just tell that. No, I just messed it up.
Good.
Yeah, no. I got 1 over x over x. Yeah, 1 over x. 1 over x ln x. Yeah, I got ln x equals 1 over x.
That's not how I'm going to do it up here, but I want to do it so you're working on it. Someone else does that too. I really like that.
Oh, wait.
I love it. I'm in love with some of the ways you guys do it.
Check out my work. Tell me if I was I don't think it is. Let me give me a second. Y prime. Okay, so it's 1 over x. Yeah, I got that. And I have a really pretty way. I would love to see it. Y prime. So like y on a. So then this is like constant. So it's just true. It's like a linear. So like stop with that constant. It's not a constant. It is. Yes, it is. But if you're doing this like I want.
All right. Almost everyone did it a different way than I did. I'm actually kind of amazed by that. But of course, that makes sense because you just did one previously. So would someone be willing to put their work on the board? Go ahead. You look excited about it, Christina. Go for it. Did you do a to the y equals x?
Yeah.
Okay, that's how you started. All right. So, and that's how most of you started, actually. A lot of you started by doing a to the y equals x. Maybe you did it my way though. I don't know. Did you? Yeah, you can do it over there. Yeah. So, I mean, I don't know. Actually, I really like your way too. I mean, after having done e to the x that way, excuse me, ln x that way, you might be tempted to do a to the y equals x. And of course, you'll get the same answer either way. Yeah. So, do you see how I'm starting? Keep in mind that isn't this just a constant times ln x? So, really, I can like factor this out using the linear properties of a derivative. So it's just 1 over x ln a using the change of base formula. But I like that. That's the same answer you guys got, but I like seeing that they both work. That's great. That's great. Anyway, so let's put that in a box too. You're right. I honestly do not declare my method better than your. I like both equally. Do you want the pass, Nick?
That's okay.
He's a senior? I don't think he's a senior.
I think he pretends.
He's a junior, but he's already like channeling his inner senior. He's like, I'm good. Pass. I don't want that. Okay. Give these two problems a try now if you haven't already started. Isn't this beautiful? Love it.
Perfect.
Crazy things like we're doing here. Yeah, whatever you were about to say, the answer is probably yeah, of course we could give you basically anything. You can turn it on. That's fine. No, that's fine. No, I mean, they have this thing for
Was it 3 over x? No.
I want at least
1 over 3x times 3 over 3x equals 1 over x, I believe. That's what I got. And then I was trying to chain rule it, but I was trying to out-chain myself. I don't know. So let's do 1 over x.
All right. The first one's interesting, right? How'd you do on the first one? I don't know if you saw that coming before you actually thought through it, but the answer is simply 1 over x. That's correct. It is, in fact, 1 over x. Let's reason our way to it. We'll do it 2 ways. The derivative of 1, that was not the hard part. Okay. ln of 3x. ln of 3x is apparently 1 over 3x times 3 by the chain rule. Yeah? So we get 1 over x. Wonderful. How could we have seen that coming? I don't know. That means that like that this is just like this whole graph must just be like a translation of ln x or something. I mean, apparently, since it has the same derivative, right? What's ln 3x pre-calc style? What's ln of 3x? Do you have a rewrite, a helpful rewrite on ln of 3x from pre-calculus? ln of 3, it's ln of 3, which is a constant, plus ln x. So I think you've just uncovered an interesting principle, right? That the ln of anything times, that is an ln of any constant times x, will just be 1 over x also, because it's just a vertical translation of the graph, right? Anyway, feel free to do the calculus, do the chain rule, you'll get the right answer too. I just wanted to make sure you had some insights on that. And then B, I don't have anything nearly as interesting to say about B, but anyone want to shout out what you got here? Who's got this one? Ian, take it away. Wait, hold up. Not everybody's listening. Go ahead. Ian.
I got 2 over ln 5
2 over ln 5
plus 2 log 5x.
log base 5x. Yeah. So over here, what happened here? We got like a 2x times.
An x ln 5, and then the
Yeah.
x is just cancelled.
Yeah, the x is canceled out. Okay, so there's not work there shown there, but that I think that works though. Yeah. Good. Huh? So it'll be 2x. So he's got 2x times 1 over x ln 5. So the x is canceled. Right. Was that good? Are we good? I'm ready to talk about logarithmic differentiation. Yeah, you might need to do one step in between to convince yourself of what he says. X, the domain is already x positive. X is positive. Yeah. So, but you're right to worry about that. Okay. All right, let's talk about logarithmic differentiation. Stop and just smell the roses for a second. Can you just appreciate that most, I think at this point, there are, we might be at the end of the road. I think there's maybe nothing in the world that you can't take the derivative of now. Except for this function. Okay. So we gotta knock this one out. So but I think once we do this, I'm trying to think hard about it. I don't know if there's really any function that you could concoct for your other BC calculus friend that they couldn't take the derivative of. So x to the x, can you just think about why that can't really be tackled completely with the tools we currently have? I mean, I think you're tempted to be like, oh, well, this is just like, x squared. I could use the power rule. Oh, wait, no, it's not really that. No, this is just like a to the x, or 2 to the x. And I could use that rule. Well, no, it's not really that either, because it's not a constant, right?
Why can't it just be x times x to the x minus 4 times the derivative of...
Because the power rule we only established for constant exponents, right? Not for like a variable exponent. It would be easy to see that that's not the case by plugging in a few numbers. Yeah, or graphing it. Jonathan?
It's not actually
That is true. Does that make it hard to differentiate though? I don't know. But I mean, you're right. Good observation. It's got extremely strange behavior for negative x values. Yeah. Pathological, I might even say. Yeah. Y equals x ln x. I mean this is the spirit of what we're about to do, but I don't agree with everything you just said. Yeah, we're gonna take logs on both sides to like anytime we're in this sticky situation where we have like stuff all up in powers, like logs come to our rescue, don't they? So we're gonna take the log of both sides, and like maybe already you can maybe see where this is gonna go. You're going to see right away that, and then we'll use implicit differentiation now. But that was like the big trick right there. That was like the big trick. And then the rest is just working out what that means in our lives. So how can we rewrite the right side? I had a hint on the board. X ln x for positive x at least. And now we have something by implicit differentiation that we can handle, right? We do know how to take the derivative of all of those things. What's the derivative of ln y? 1 over y, oh wait, times dy dx by the chain rule. X ln x, what about that? That'll be, yeah, 1 plus something, 1 plus, well, work it out. You might need to, here, I'll write it out here. It's first times the derivative of the second, so that's x times 1 over x, plus the second thing, ln x times the derivative of the first, which is just 1. So I think we're in a good place here. So that's just 1 plus ln x on the right side is the derivative of x ln x using the power of the product rule. And then we're solving for y prime, right?
Right.
Yes, Rebecca?
I think I might just have my math mixed up, but why can't you just do like ln x over ln x and make it 1?
Where are we looking? Way
So from the first step.
here.
Yeah, like isn't that equal to ln x or like log base anything over log base? Like
Long base.
like ln x over ln x. Oh no, I'm an idiot. I'm sorry. I'm mixing up my loxels. Okay, never mind.
All right. It's all good. I like questions that answer themselves. I had to think hard about what you were saying. So yeah, multiply both sides by y, and I think we'll have our answer, except wait, hold up. We often don't mind answers like that, but if it's really easy to solve, to give a derivative in terms of x, then we should, right? And here's an example where it really is easy to put it in terms of x, because we have the original function as an explicit function of x. So there's no reason we should have a y in our answer. So I haven't finished this yet. I'd like to still substitute back our function of x in for y. So our final answer will be x to the x times 1 plus ln x. So this is how these feel. This is called logarithmic differentiation. Pretty nice technique to take the log of both sides and then take derivatives. Really, I mean, all throughout today and all throughout this course, pre-calc to the rescue, right? Using property of logs to get us through all this. So, any questions so far, comments? I've just one more slide, and it's you practicing with another problem like this. So this is not so much a new derivative rule. This is not like, oh, okay, I gotta write down the derivative of x to the x in my little book, right? Memorize this, x to the x times 1 plus ln x. No. This is a technique, right? So it can be applied to all sorts of situations like this one too, how about, right? Anytime we have f of x raised to the g of x powered, call on, from the heavens, call on logarithmic differentiation. Come down. So give this one a try. I don't have much to say, just see how you do. Maybe we'll have someone come up and write it up there once I get it. Take the log of both sides. Start by doing that. And by that I mean the natural.
We just made cosine dx.
By the way, the domain is something, I don't know. I guess for positive x values. I guess that's the part about that. Incredible how
not gonna have it. Yeah, I'm house, I was doing this. I can do some very weird factoring. I don't think that'll help any of us. Wait, let's back it up. Oh, yeah, there's cosec.
Let's get someone to put this up here. Albert, you want to showcase your work?
Yeah, I'm actually almost done.
All right.
I'm almost done.
You better get out there quick. All right, maybe as just one last activity before we leave today, I really do want to prove that you're powerful. Okay. I really do want you to try this. Could you write down for your friend next to you a function that they should take the derivative of? Make it as crazy as you like. Right? But I mean, you just can't even come up with anything. Use compositions, use products and sums of functions, quotients, anything you like. I think they should be able to take the derivative of it successfully, right? So do that. Actually do that. Like, come up with a crazy function for your friend to take the derivative of. It doesn't. Maybe you don't need to do logarithmic differentiation necessarily. That might be.
I tried to get a little too fancy. Oh, that doesn't really belong there. No.
I got it.
Hurry. Don't hurt yourself.
I don't know if this is right or not.
We need some ice up here.
I took that code.
This is cocktail
I'm
spot.
trying to get really excited.
Have an intro read.
I know, but this is cosine. X minus 1. I'm trying to
Write it neatly though, Albert.
English or third grade history. That's what I'm questioning.
See if you can do it before the bell. Do you think he can or not? I don't know. He still has like a minute and a half. I think he might be able to do it. It has to be legible. Is he gonna do it? I get it. Still has a little over a minute. I guess that's right.
ln of what at the end?
Yeah, what is that?
Sin x times ln of sin x.
Alright, I mean, you may be getting credits right now, but on a test or quiz.
Yeah, really, my only problem was that I
So for those who can't read this, this is sine x to the cosine x times cosine squared times, I think that's supposed to be a sine, right? Or no, cosecant?
Yeah, I don't like this actually. I'm going to Z, alright? I was
Alright, yeah. And this is minus sine x ln sine x.